Okay, are we filming? Okay, alright, let's begin. Hi, I'm Shauna, and welcome to Math Express. Yay! Get out of the way, you cheeky Shauna. I am going to teach here, because I am definitely a whole lot smarter than you. No, I'm smarter. I am the smarter one. Sorry, I'm sorry. We're so very sorry. We won't do that again.
Now, who of you is the main teacher? Are you all teaching?
No. Fine. Guess we'll be teachers for later.
Stop lesson.
How about... What are you doing?
This building.
How about we be the teachers? That'd be a very good idea. You said you were going to be the teacher of the next video we're going to start.
Do you guys know that this is actually the net for a cube?
Yes. Yes! A cube has 6 faces that are all squares. But we're not learning about cubes.
But I thought we were learning about geometry!
We are learning about geometry, silly. It's just not with 3D shapes. You guys should know what a cube is, right?
Actually, what's a cube?
I am so glad you asked. A cube is a 3-dimensional shape. With all 6 faces squares. This means
What's
that...
a square? What's a face? What are shapes? What is life? What is everything? What's a house? What's a fries? What are fries? Why do people call me French fries?
Now, anyways, I thought we are going to be learning about something closer to Flatland, or what I like to call Flatland, because it's 2D shapes.
Okay, well then I think I should flatten my house. Hey, alligator, could you wreck this house for me?
Oh, sure. Yeah!
Thank you.
Uh-huh. You're welcome. How is that even possible? An alligator never reveals his secrets.
Anyways, continue on the lesson while I flatten out my house.
Yes, flatten. That's very good. Keep on doing that. Anyways, I thought we should start something closer to 2 dimensions, which... What are you doing?
I'm just sad because I had to break apart my house. But I think this is my house net.
Yes, it is. Well done.
Continue the
So we
lesson.
shouldn't learn about nets yet.
Okay, keep my house. Keep them as normal shapes.
Yes. By the way, a net is a 2D representation of a 3D shape with flat faces. So anyways, enough of that. I thought we would start something closer to 2 dimensions, which is drawing, estimating, and measuring the distance around shapes. Yes, like that. Good job. Like a square, for example. Look at this. So, this shape has 4 square corners, and all of these sides... Huh? What is that? Thought I just heard something. Meh. Oh well. Guess it was just the strong winds.
You're imagining things.
Oh, yeah, right. I'm probably hallucinating. Silly me. Now, what's interesting about this is that, although it doesn't look like the orange square, we could tilt it, and it would look exactly the same shape. Who's there? Oh, Vicky, why are you here? Let me guess, you want to participate in this class? Never would have guessed. Oh, good, he's okay.
Vicky, do you even know what a class is?
You don't know what school is? It's an educational system. You should always get that. Second graders, I am sure you positively do know what school is, right? Now that you've been through kindergarten and first grade, and currently second grade, which is right now, and we are going over it. So, you should definitely know what school is, or else something's totally wrong with you. Anyways, continue. So, anyways, what's interesting about me.
Okay, that's it. I am getting out of this classroom right now.
Me. Okay, well, I guess Vicky's.
You're welcome.
Yeah, okay. Well, yes, I guess Vicky is no longer officially allowed to school. Now, anyways, what's special about this square is that this square has what I like to call ticks or tick marks. They are called ticks because they look like that little annoying bug that's called a tick. You try to scratch it off. It's kind of like a little line when it's so blurry. So this kind of represents a blurry tick bug, except it's totally not a bug. It's just a tick mark.
But don't think that your square is infested with ticks.
Yeah, don't think that. If your square was infested with ticks, then
I don't know what's wrong with your square.
Then I don't know what's wrong with your square, guys. Yes, ticks are actually very dangerous. The common side effects include... Don't list the side effects. We're getting into math here, not health. All right, sorry, sheesh. So I think what Shauna's trying to say is that although squares could have tick marks and not ticks... It is still the same thing as the orange square. It's just that they have tick marks so that they could be measured in centimeters. You're right! They could be measured in centimeters. This is why they have tick marks over here. One line over here represents 1 centimeter, which means this line must represent the other centimeter. And this line must represent the other. 1 plus 1 plus 1 is 3. So there's 3 centimeters.
Although the ticks seem insignificant, they're actually very important.
They are extremely important because if you don't list the ticks, you will never be able to measure any shape in centimeters.
You won't be able to find out the perimeter or the volume or the area.
That's right, but the volume is only for 3D shapes.
3D shapes?
Oh
no.
Oh no. Well, actually, second graders have actually graduated one of the first stages of 3D shape knowledge, just classifying them and composing them, putting them together.
Did I say 3D shapes? Oh no.
That's totally a 3D shape. And finding the area, finding the volume of such a shape is too complicated. It's way too complicated, I tell you.
Well, not really if you split these in half.
Oh, yeah, true.
Two?
But what I'm really saying here is that these tick marks are so important, that if they are absent, then it will be nearly impossible to measure the side lengths. And since this is a square, and since one of the side lengths is 3 centimeters, all the other 3 sides have to be equal. So guess what, everybody? The rest of the 3 sides are 3 centimeters as well, because they have to be equal, and that's a square. Now, finding the perimeter of such a shape, you're correct. Perimeter, yes.
Perimeter.
Yes. The perimeter is the total distance around a shape, and it's really kind of easy. What you do to find the perimeter of any shape, really, is just to add all the side lengths together. So, let's look at this square. If we acknowledge that all of these are 3 centimeters, we could take those 4 3s and add them together. 3 plus 3 is 6. And another 3 plus 3 makes another 6. And 6 plus 6 is 12. So the perimeter of this square is 12 centimeters. And how do we know that? Oh, because 3 plus 3 plus 3 plus 3 is 12. 3 plus 3 plus 3 is 9, and 9 plus 3 is 12. So, yes, 12 centimeters is the perimeter of the square. Finding the area of a square is actually pretty easy as well. Although area might seem like a pretty complicated word to learn, you may have theoretically surprisingly learned it in kindergarten and even first grade. What? Yes, kindergarteners start counting when they reach a certain age. And since area is simply just counting all of the squares that the square could be split into, then theoretically, kindergartners already learned about area, but not too much about it. The area of any square is the side length times its own side length. So, for example, this square has 3 centimeters for one of its side lengths. The area of the square is very, very easy. All you have to do is multiply one of the side lengths by itself, and you'll get the area. 3 times 3 is 9. So the area is 9 square centimeters. Area is measured in square units, so that's why we say square centimeters. What was that?
Shauna, you're going crazy.
Yeah, probably paranoid. So, Vicky!
Not again!
I just kicked you out of the school! Really? Fine, you can come back into school. But this time you must promise to behave. Now, what you missed is a lot of important stuff.
Yeah,
very important. Which was about the perimeter. Did I say it right? Perimeter.
And while Shauna was explaining what they were doing while he was gone, of course, Vicky took another nap.
Wake up! I know you love to snore, but can you please stop snoring so loudly? Yes, Vicky, please. We're trying to learn here.
Yeah.
Thanks, Henny, but I don't need your help. Oh, okay. So, anyways. Did I just see a candy cane or something? It's like an orange candy cane.
Continue on your lesson.
Sorry. Anyways, so, Vicky, to say for short, we could tilt a square like this to match the shapes up. And they are similar because they are both equal and they're both squares after all. And if we count 1, 2, 3, tick marks represent centimeters, and tick marks are not ticks, by the way. 1, 2, 3, 3 centimeters. That's 3 centimeters. And since this is a square, the other 3 sides have to be equal. So these 3 sides are also 3 centimeters. And the perimeter, or the distance around the figure, is... Don't worry, I'm totally not going too fast at all.
But Shauna realized that it wasn't Vicky's crying, it was Vicky snoring.
Oh. Ooh. Me? Good, you're right. Now, anyways, the perimeter is this plus this plus this plus this. It's probably giraffe or something. Yeah, you're right. I'm just imagining things. Now, anyways.
Wait, we're focusing on 2-dimensional shapes?
We're focusing on 2-dimensional shapes. Flat shapes. Time to smash this thing. Ah! There. Wow, good job. Now, anyways, the perimeter distance around the figure is this plus this plus this plus this. Side length plus side length plus side length plus side length.
Vicky gets it. Go to the continue
Okay, 3 plus 3 plus 3 plus 3 is 12 because 3 plus 3 is 6, 3 plus 3 is 6, 6 plus 6 is 12. So the perimeter is 12 centimeters. The area of any square is actually quite easy too. The area of a square is the side length times the side length. So the side length times itself, for example, 3 times 3 is 9. So the area of this square is 9 square centimeters. And area is measured in square.
Mickey gets it. Can you please continue with what you were doing before Mickey came?
I'm sorry. I just love two-dimensional shapes. Now, anyways, I'm paying attention. So now we could see why these tick marks are so important in geometry, especially in junior high school. I could tell you junior high school geometry shapes use these tick marks all the time. You don't know it, but sometimes it appears everywhere. Literally everywhere. Do you see those yield signs when you pass by the road? That looks like this shape, except totally different, but it's still a square. So, yes. Number 2 is a little different because the side lengths are shorter than these side lengths, and they are not even measured in tick marks. But don't worry. All we have to do is simply just draw tick marks in those side lengths. Let me just get that. Thank you. Now, if we put this over here, tilting the square, the square just moved.
You're kidding.
Yeah, you're right. Squares can't move. I'm probably just being crazy. It's all in my head. Sorry. Continue. Anyways, focusing on shapes, two-dimensional shapes. Now, when the green square is tilted like this, it does not look like the smaller square, but if we tilt it like this, it does. So, this is a square because although it does not have tick marks to show that all of the sides are equal, we could see that both pairs of sides that are the closest to each other are like next door neighbors. Equal next door neighbors. That's very fun to say. Oh yeah, kind of does. Look. 1, 2. They're closest together. They meet at a common point. That's right. And when they meet at a common point, the points that No. The point that the two sides meet at is equal. Because half of the point on half of the things... Sorry.
Shut up!
Sorry.
Flowery needs to teach this.
Oh, yeah. Sorry, Flowery. Go ahead. Yes. So what Sean is basically trying to say is that if a square has one point in which two pairs of closest next-door neighbor sides have a point, then the other 3 points must also be shared by the rest of the pairs of the two neighbor sides. So
How much longer till we're done with this page?
Alright, we are only going through 149 to 152. Don't worry. Only 4 pages. Very easy stuff. Anyways, that means all of the points are equal. They are square corners. Now, to measure this without tick marks, we will just have to draw some. Does anyone have anything to draw with?
To draw with?
Yes.
I can go grab something.
Okay. Can you?
I can.
So get it!
Yeah, but I didn't say I will. I said I could. Okay.
There we go. Now, while Fries is getting that super important writing utensil, or tool as I should call it, we could just estimate what these lengths are. Or actually, no. We could just figure out why all of these are square corners. Oh boy. Now, the reason why all four corners of this square are square corners is because when you annotate, that means to show in detail the corners are shaped like squares. So square corners are basically corners that are shaped like squares and could not only be found in squares and rectangles, but could also be found in triangles as well. Or pretty much any shape.
You guys do, sorry.
Or pretty much any shape with a square corner can have a square corner. There we go. Now, with something to draw with, we could help find the measurements of all of these sides together. Okay, we're rounding to the nearest centimeter, so this may not be this may not be exact, but it is approximate. So, you ready, guys? Okay, this is one side long. This makes one tick mark over here. This is also one long. So this 1, 2 makes 2 centimeters. And since this is a square, we could assume that all of these are also 2 centimeters. Let's double check. Yes. These are all 2 centimeters because we could see that the tick marks represent these centimeters cut in half. This may not be cut in equal halves, but this is an approximation of equal halves. So, these are all 2 centimeters, but the perimeter of it is to basically add all of these together. So, let's do some math. 2 plus 2 is 4. 2 plus 2 is also 4. 4 plus 4 together makes 8 centimeters. Perimeter is not measured in square units, so it's not 8 square centimeters. It's instead just 8 centimeters overall. It's just measured in regular centimeters instead of square centimeters. But in case you want to find the area of this square, you basically just multiply 2 by itself. Because in order to find the area of a square, you just multiply one of its side lengths by itself. So 2 times 2 is 4. So the area of this square is 4 square centimeters. I think we're getting the hang of this. I think this is getting pretty easy. Yes. Now we are getting into a very humongous square. Humongous square over here.
Wait, how many pages?
Oh, 1, 2, 3, 4. 4 pages. This is a very humongous square. It's roughly the same size as this square over here. It's roughly the same size. So, I guess we would have to find the lengths of these sides this time. Let's see, rounded to the nearest centimeter. That makes 1. And that makes 2. And that makes 3. Relax, the class will be over soon. Wait a second. Yep, just what I thought. Wake up, buddy. Thank you.
You really need to watch where you're going, Flower.
Yeah, I really do. Now, anyways, getting back to our lesson, we counted the centimeters, and now, just to clarify that this is a true square, we need to figure out if this is the exact same length as this, because all squares have 4 sides equal.
Are you and Shauna going crazy today?
No. We just we just like to do this. It's a fun dancing. It's a fun dance. Woo! Woo! Like I said, very fun dance.
The lesson.
Sorry. Focusing. Now, we counted. Now, anyways, we counted all the centimeters. 1, 2, 3, 4. Together, that makes 4 centimeters long and 4 centimeters tall. So this is a true square because both pairs of the closest next door neighbor sides are equal. So we could assume that this is a square. This means that we add 4 times because basically there are 4 4s and 4 is in each 4, as I should say. Yeah. 4. Huh?
Start with you.
Okay. 4 plus 4 is 8. And 4 plus 4 is 8. If we add the two 8s together, that makes 16 centimeters. So the perimeter, or distance, around this square is 16 centimeters. And surprisingly, the area is also 16 square centimeters. You want to know why? 4 times 4 is 16, and 4 times 4 is equivalent to 4 plus 4 plus 4 plus 4, which is also 16. So guess what? The perimeter and the area of this square is exactly the same. But for some weird reason, the perimeters and areas of these two squares are completely different. That's interesting.
Isn't there a saying that goes, all squares are rectangles, but not all rectangles are squares?
That's actually quite correct, because you theoretically learned that in kindergarten and first grade when we have been introducing squares and rectangles. Squares are a special kind of rectangle, my friends. They are not a three-sided shape, obviously. They are special kinds of rectangles because, just like rectangles, squares have square corners, obviously, but they also have 4 equal sides. That's what's special about them.
And that's you?
Yes. Anyways, now for a rectangle that is not a square, which is called an oblong. O-B-L-O-N-G is how you spell oblong. The perimeter is pretty different, but still exactly the same, except for sides with different lengths. So, this is a rectangle, meaning that 2 of its sides...
Yes?
Alligator? Yes. Nom 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 nom. Nom 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 nom. Nom 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 nom. Sorry. Lick Boo, I didn't even know you got here.
It is with you, listen.
Okay, anyways, continue. This means
Who's that?
no one. Okay, anyways, since it has 2 long sides and 2 short sides, the lengths of 2 of the long sides and the lengths of 2 of the short sides will be different. Meaning...
So good.
Are you done?
No.
Of course not. This means... This... Sorry. This means that both pairs of closest next door neighbor sides will not be equal. Look carefully. There are 2 tick marks here, but 1 tick mark here. Those are not equal. Think of it as a mathematical inequality. 1 is not equal to 2, is it? Nah. 1 is not equal to 2. Obviously, that's how you could tell that a rectangle has sides of different lengths. Nice house.
Thank you.
I'm gonna smash it though. So get off. Fine, I won't smash it. I like smashing things.
I do.
Okay. Anyways,
It's got a chimney.
cool. Very cool. Anyways, for a rectangle, we need to add and find all of these missing side lengths, but all of the side lengths will be different. So,
I'm trying to put the chimney in the middle of my home.
and I could see you yourself is proud.
Heck yeah.
Now, anyways, or are, sorry, I don't know. Now, anyways,
This is my chimney. What do you think?
it's very fascinating. Flowery, focus. Sorry, I'm sorry. Very sorry. I love her house. Now, anyways. 1, 2, 3.
4, 5, 6, 7, 8, 9, 10.
How could the rectangle have 10 centimeters? There aren't even close to 10 tick marks. And by the way, kids, be careful. 10 tick marks in a line does not make 10 centimeters. It makes 11 centimeters. It's an abstract and complicated concept in splitting and partition, but we're not going to learn that. So, 1, 2, 3, 1, 2, 3, 3 centimeters for the long sides, and 1, 2 centimeters for the short sides. The perimeter of a rectangle is technically the same thing, except with different side lengths. So,
Side length?
side lengths.
What's the side length?
It's the length of a side.
What's the length and what's the side and what's the up?
Length is how long it is. Sides are edges.
What's long and what is edges? Yeah.
Okay, we'll continue. Anyways, now, instead of 3 plus 3 plus 3 plus 3, or 2 plus 2 plus 2 plus 2, it's going to be 3 plus 3 plus 2 plus 2. Because 2 long sides, 2 short sides. So, but we are going to do this kind of formula so that it's easier. 3 plus 2 is 5, and then another 3 plus 2 is another 5, obviously. So, 5 plus 5, if we add them together, makes 10 centimeters. See? How long did that take me? Like half of a minute, like a quarter of a minute. So, that is how you find the perimeter of a rectangle.
Did you know that a quarter of a minute is actually only 15 seconds?
Yes, that actually is true, because 15 is 1/4 of 60.
It was the last thing I learned
The last thing you learned
in a while.
in a while? What grade are you in?
What's a grade?
I don't know how you're even in this school right now. Anyways, so...
I'm actually 17.
Oh, then you should already know about that, silly. Now, anyways, if we double check adding the two... Checking twice. Now, 2 times. Now, if we double check by... by adding the 2 3s and the 2 2s together, the 2 3s make 6.
Why are these?
And the 2 2s make 4, and 6 plus 4 is 10. So, we are right, it's 10 centimeters for the perimeter. The area of a rectangle is quite as easy as a square's area, except it's different. This time, the area of a rectangle, that is not a square, be careful, is one of its side lengths times another one of its side lengths, because they are not all equal. So it's basically the length times the width. So it's A equals LW, that's the area. So if we multiply 3 by 2, we get 6, because 3 by 2 is the same as 3 plus 3, which is 6. So the area of this rectangle is 6 square centimeters, and the perimeter is 10 centimeters. So the perimeter and the area are not the same. So we could say that the perimeter is greater than the area. But what about this rectangle? Looks like the square corners are very close to each other. Look how close to each other they are. Look how close to each other they are. Oh my goodness. They're almost touching each other. Yes, it looks like the short sides are really going to be very, very short this time. let's see what the measurements of these are. So, 1, 2, 1, 2, 3, which means 1, 2, 1, 2, 3. So this is 3 centimeters, and this is only 1 centimeter because this line is too small to mark any tick marks. So this is basically just 1 centimeter.
What's the tick mark?
We literally just went over the entire thing.
Okay.
Basically, a tick mark is a mark that looks like a tick, but blurry. So, anyways.
What's a mark? What's a tick? And what does it look like?
You really...
Video!
Sorry. Anyways, if we look over here, the long sides of this rectangle are similar to the long sides of this rectangle. But the main difference is that the shorter sides of this rectangle are shorter than the shorter sides of this rectangle. Now, anyways, the perimeter should be easier to find because there's 1. 3 plus 1 is 4, 3 plus 1 is 4, and 4 plus 4 together makes 8 centimeters for its perimeter, or its entire distance. If we double check, 3 plus 3 is 6, 1 plus 1 is 2, and 6 plus 2 is 8. So yes.
My chimney!
Oh,
I'm late!
excuse me.
You're excused.
You're supposed to never be throwing shapes in here.
I'll be right back.
Okay, she might need some time to recover from the playtime area. Now, back to the... I'm sorry, that's just a way to make him pay attention. I won't do that again to you guys, but that was really scary. Okay, now, if we double check, that makes 8 centimeters, and the area is one of its side lengths times the other side length. One is one of them is 3, and the other is 1. If we multiply 3 and 1 together, that makes 3. Because 3 times 1 is the same thing as 3 plus nothing, which is basically just 3. So, the area of this rectangle is 3 square centimeters, and the perimeter is 8 centimeters. The perimeter is greater than the area. Wow, this time, we're really starting to get real big here. Real big into this rectangle. Wow, that's a big whopper. Look at how far apart its angles are. Yeah, its corners are very far apart, as you could see here. Now, what you probably notice, what is odd about this one? Well, it is labeled with letters. And surprisingly, so are the squares. But you're probably wondering, why are these labeled in letters? Why can't they be labeled in anything else besides uppercase letters? Well, it may be surprising for you to learn that uppercase letters are not always playing a major role in learning about the alphabet. In fact, they appear in mathematics all the time in here, and even in junior high and high school. So yes, letters do not only play a role in the alphabet, they can also play a role in mathematics, because they help us to label things, which we see here. This is side EF, because there's E and F with it. This is EH, HG, and GF. See? Although this is FG, GF is basically FG, because FG is basically GF, but backwards. So, another name for side FG is GF. Yes, so, meaning that another name for the side EF is FE. GH is HG, and HE is EH. It's the exact same thing for the rectangle here, except with different letters and with sides of different lengths. So, WX is XW, XY is YX, YZ is ZY, and ZW is WZ. So, see? The side with two letters could be the same thing as the side with the two letters swapped around. WX is equal to XW. Because basically, WX is XW, but in a backwards motion. It's a kind of complicated, abstract concept where we go forwards and backwards with drawing lines. But we don't need to learn about that too much. Now, anyways, this is a real whopper. We should really start measuring. We should really start measuring the sides now. Looks like the centimeters are getting smaller. Do you notice that? That's because the sides are getting bigger and longer. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if we double check over here, there's 1, then 2, then 3, then 4, then 5, which means 1, then 2, then 3, then 4, then 5. So both of these are 5. Now, we need to measure these two. 1, 2, 3 tick marks here make 4 centimeters, which means that this must also be 4 centimeters. Let's double check. There is 1, and 2, and 3, and 4 centimeters here. And 1, 2, 3, 4 centimeters over here. So, if we look, the long sides measure 5 centimeters, and the short sides measure 4 centimeters. Now it's time to find the distance. 5 plus 4 is 9. 5 plus 4 is 9. And if we add the two 9s together, we could see that 9 plus 9 is 18. So the perimeter of this rectangle is 18 centimeters, because it is basically just 9 plus another 9, which is 9 times 2, which is 18. But that is not the area of the rectangle, because the side lengths are 5 and 4. And multiplying 5 and 4 together makes 20, not 18. So, the area of the rectangle is 20 square centimeters, because 5 times 4 is 20. Just think of it. Skip count by 5 4 times. 5, 10, 15, 20. See? That's 4 times. That is 20. So skip counting is an easier way to find the areas of such shapes if you don't remember how to. So, now, let's double check. 5 plus 5 is 10. 4 plus 4 is 8. We should all know what 10 plus 8 is, right? 10 plus 8 is 18. So it's 18 centimeters. Yes. And the area is 5 times 4, which is 20. So the area of this rectangle is greater than the perimeter. Also interesting. Huh. Oh, and in case you're wondering, you could estimate or make a careful guess of how many centimeters each of the sides have. So, WX was estimated to have 5 centimeters, and when the person measured it, it was 5 centimeters. XY was estimated to be 7 centimeters, but when they measured it, it was 4 centimeters. So, it's never wrong to get answers wrong, as long as you're learning from those wrong answers, because learning from those mistakes could actually help you learn and grow your brain faster so that you could succeed in life and in school as well. Now what we are going to do is to do the same exact thing, but with triangles. What's a triangle? A triangle is a shape with 3 sides and 3 corners. And in case you didn't know or forgot, a square is a shape with 4 sides of equal length and 4 equal square corners. And a rectangle is a shape with 4 sides, 2 long sides and 2 short sides, and also 4 equal square corners. But a triangle is kind of different because it either could or could not have a square corner. So it does not always have to have a square corner, but it could have a square corner. So a triangle has 3 sides and 3 corners. And the distance around such a shape is easier because that shape has a fewer amount of sides. So yes, we should be thankful for this. So now these tick marks again, 1 and 2 centimeters across, 1, 2 centimeters across here, and 1, 2 centimeters across here. 2, 2, and 2. Do you guys notice something interesting? All of the sides are equal in a triangle. What is a triangle with all 3 sides of equal length? Oh, that is actually known as an equilateral triangle. Oh, we're too young to learn about that. Yes, so we're going to put that aside. Instead, we're just going to say that it's a triangle with 3 equal sides because all of its sides measure the same exact thing, 2 centimeters, 2 centimeters, 2 centimeters every time. The perimeter is simply just adding all of these together, which only require adding up 3 of them. So 2 plus 2 is 4, and 4 plus 2 is 6. So the perimeter is 6 square, sorry, not square. The perimeter is 6 centimeters. And speaking of square centimeters, which I mistakenly said, the area of a triangle is kind of difficult, but is actually also kind of easy. It's just that it requires a few extra methods. The area of a triangle is one of its side lengths times itself, but this time you divide those 2 sides in half. Yes, so it's basically just half BH. So, wait, no, sorry. So basically you have to measure how tall it is, right, a square corner, and then to find the area of the triangle, you need to do 2 times how tall the height is and divide that by 2. So let's measure this. So if we look over here, that is 1, 2, 3. That is 3 centimeters. The height is 3 centimeters. And the base length is 2 centimeters. So the area of a triangle is basically the base, which is this, times the height, which is this, divided by 2. So 2 times 3 is 6. And 6 divided by 2 is 3, because 3 plus 3 is 6. So the area of the triangle is 3 square centimeters. Also very interesting. The area of this rectangle is half of the perimeter of the triangle. Very interesting. But it does not only occur in triangles with all 3 sides of equal length. You could find the area of any triangle pretty much as long as you find the height of one of the triangles and multiply its base length by its height and divide that by 2. Very, very simple. Now, let's measure these. 1, 2, 1, 2, 3, 4, and 1, 2, 3. Interesting. This is 1, 2, 3 centimeters this way. 1, 2, 3, 4 centimeters this way. And 1, 2, 3, 4, 5. 5 centimeters this way. 3, 4, and 5 centimeters. Those are 3 completely different numbers. This triangle has all 3 sides of different lengths. That is known as a scalene triangle, but we are too young to learn about that, so instead, we are just going to represent it as an unequal triangle. But it does not mean that it's not a triangle. It is a triangle, but all of its sides are just unequal in length. So basically, no matter how long or short the sides are, and no matter which way round the triangles are, they are still triangles. Oh god, not this again.